everybody, this is Jim Hester. I'm a software engineer at RStudio. Functions in R that need to take optional values often use the function missing internally to determine if a given argument is missing or not. Missing returns true or false if a given argument was supplied by the user. However, this function makes it challenging to program with and also less explicit to the user which arguments are missing. An alternative using null to denote a missing argument is completely explicit with which arguments are missing and also trivial to program with. Therefore, it is my recommendation, RStats tip number 2, avoid missing and prefer null. Let's explore why this is with an example. So a function in base R that uses the missing argument, the missing function, to determine if an argument is missing or not, is the sample function. This function takes 4 arguments, but we'll just be focusing on the first 2, x and size. And you can see that they both have no default value. If we call sample with 2 arguments, it samples the values in the first argument the number of times in the second. But if you can also call sample with just 1 argument, and in this case, it just samples all of the values. We can see how this is implemented if we look at the body of sample and see there are 2 calls to missing, here and here, to missing size. And in this way, the size value is shown to be an optional argument. So the first drawback to using missing is that it's not clear from just looking at the arguments, because both x and size have no default, you would expect both of them to be required, but actually only x is required. So the first drawback is it's not explicit which arguments are optional or not. The second drawback is when you're trying to wrap a function that uses the missing argument. So if we try to wrap sample with the function sample n, which does nothing but changes the default of size to 1, we'll see what happens. So if we call sample1 with 1 argument, we get what we want, a single value of sample. We return it, if we call that function sample n with 2 arguments, we get 2 arguments, exactly what we want. But there's no way for the user to fall back to the behavior of calling sample with no arguments, i.e. sampling all of the values. They try to pass null, that results in an error, or if you know that R, to denote a missing argument, has a special value that you can obtain with this strange construction, quote, expr, with no value. So if we use this to create our special, and if we just see what this looks like, this just looks like an empty value down here. And if we try to call this with our argument, with our sample n, we get an error. So let's try a different implementation. Let's say you just, here we'll use missing in our implementation. So if size is missing, we'll call sample with just 1 argument. Otherwise, we'll call it with 2 arguments. Let's see what happens with sample n2. We call it with 1 argument, and already we're not getting what we'd want. Because remember, here we're trying to change the default to 1. So we don't expect only 1 value. So that's not quite doing what we want. We call with 2 values, that works, but again, null and our special missing value does not work. Let's try a different implementation, sample n3. Here we're using doCall with a list of all of our arguments and calling the sample function. Let's see what happens here. We first call sample n3 with 1 argument. We get what we want. We call it with our 2 arguments, and we also get what we want. Calling with null does not work, but calling with our special value, quote, expr, does work. And this gets us the behavior of sampling the entire vector. So this is actually pretty close to our goal of what we want. We have to use this little strange construction of using doCall And more importantly, we have to know about this special value of missing and how to supply it to the function. And I don't think it's reasonable to expect users to know about this value or how to create it. So let's try to make a different implementation that's a little nicer. So sample n4 aims to do what sample n3 does, but instead of users supplying quote expr, they can just supply null. So let's see how this works. So we're capturing the call using match call, then checking if the size argument is null, and if it is, we're substituting with our special value. Otherwise, we're substituting with the value size, and then we're calling doCall on the result. So let's run this and then check our three cases. So one argument works as we want, two arguments work as we want, and supplying null works as we want. So this is actually a good solution to the problem of wrapping the sample function. However, and this works really well for one argument, but what happens when there's not just one argument size that is using missing internally, but 2, 3, or more arguments are using missing? How do you handle that case? So sample n5 is an implementation that would handle that. So this is much more complicated, but basically this is generalizing our previous method. So we're capturing all of the default arguments, we're getting all of the default arguments, we're getting all of the called arguments, and then we're taking all of the called arguments plus any defaults that were set. And then if any of those arguments is null, has a value of null, we're substituting those arguments with this special value, and then calling doCall on the result. So again, let's run our sample 5 for one argument, two arguments, and a null argument. And this is, again, has the behavior we're looking for. But this implementation is definitely non-trivial. And I would not expect anyone to come up with this. It took a decent amount of trial and error to get to this point. So clearly, it is possible to wrap functions that use missing, but it's definitely not easy to do. And it also should be noted that both match call and doCall have some performance implications. So this wrapper function is going to be less performant than the equivalent naive function would be. Well, how about if we use null instead in our original sample function? So if sample, instead of using missing internally, was just using null, and we'll call this sample2. All I have done is change the isMissing size parts of the function to isNull. And if I run this, just with one argument, you get the same behavior you do with the regular sample function. But now we can create a very simple wrapper without any difficult implementation like we had with our sample n5. So sample 2n just calls sample2 with size and passes it directly. So now we can do our three examples: sample 2n with one argument, sample 2n with two arguments, and sample 2n with null. And we get exactly the behavior we want. The implementation was completely trivial, and it's extremely clear if size is an optional argument or not. And clearly, this is much easier to deal with programmatically than functions using missing. So, in conclusion, my suggestion is to avoid missing and prefer null when you're defining your functions that take optional arguments. Null makes which arguments are optional completely clear, whereas missing requires users to either look at the implementation of the function or to look at the documentation to determine which arguments are optional. Workarounds with functions using missing are possible, as I showed, but it's fairly difficult to work out the implementations. So that's really not a great solution either. In contrast, if a function is using null to denote a missing value, then wrapping those functions is completely easy and trivial. And if you'd like to read more, there's a chapter in the principles website, tidyverse principles website, about required arguments that mentions these issues. Thanks for listening, and I'll see you guys next time.